All right, hi. I'm Scott Powers from Dell Technologies. I'm in the technical marketing organization for what we call integrated solutions, where we build all kinds of architectures for really fascinating solutions with partner software built on Dell infrastructure. So I'm here today to talk to you about boundless VDI, virtual desktop infrastructure, with NVIDIA Omniverse, a really exciting application that we're going to show you a short demo of today as well. And I've got a friend Charlie here from NVIDIA as well, if there's any questions, which we'll probably take after the session because we only have 15 minutes. So I'll try to go through the few preliminary slides here, kind of set things up, talk about the needs here for 3D virtual collaboration and how we do it over VDI, and then show you a short demo that's really the exciting part of the talk here today. So we know that working from anywhere, this is basically intuitive to most of us at this point, but we've done surveys, we've gotten the data. Working remotely is here to stay, and the permanent remote work is essentially doubled since it was before pre-pandemic times. People expect to be able to use their own devices, at least when they need to, and a high percentage of people expect to be it seems to be going on its own with timings here. Expecting very, very high performance to do anything from anywhere, not just work from anywhere, but to do anything from anywhere. So traditionally, VDI has had several popular advantages, namely security. It's inherently more secure than distributing apps and data out to desktop environments. Cost, especially through the ease of end-user management as opposed to full desktop management. And increasingly now, performance. So one thing we'd like to say is this is not your father's VDI. It used to be known for what we think of as task workers and knowledge workers, single-focused tasks such as retail, bank tellers, airline terminals, and so forth. But increasingly now, there's not just a need, but there's a very strong ability to deploy very high-performing applications over virtual desktop infrastructure. And that's really what we're showing here today and what we've done together with NVIDIA with Omniverse. Okay. So Omniverse is about 3D collaboration of high-performance visual creation and production applications. This is a very tough thing, right? The graphics industry have large teams of designers, just hundreds of people collaborating with a broad range of skills, many different vendors, many different tools, and the workflows are highly complex. And until recently, oftentimes these processes were serialized. That's why they call it a pipeline in essence. And there's further challenges too with doing this, with collaborating on these 3D graphics. The so-called new normal, you can't just walk around and collaborate with people ad hoc. It has to be more formalized. Data gravity with these huge, huge files that are distributed across hundreds, if not thousands of miles, or from country to country. Let me just go back. Let me keep up with this. I think this is, it seems to be advancing manually or automatically. So what we're getting to, though, this is the heart of it right here, is NVIDIA Omniverse, right? Which is a 3D collaborative application that's highly scalable, leverages multi-GPU infrastructure, virtual GPUs, virtual workstations, and allows designers to work on the same files together in real time, which in itself is impressive. But what's really impressive is that we can do this over a VDI infrastructure on built on Dell infrastructure. And that's what we've collaborated on. We've produced a design. I have some information about where you can find this and such at the end. But this leads right into the demo. So it's a recorded demo. It would be way too complex to show a live demo here, certainly in the time we have. So I'm just going to let this play. I wanted to maybe advance it a short way. There's 3 scenarios in here that I wanted to talk about. And I'm just going to go a little bit further here and let it run and try to explain it. So this is an example of, obviously, of graphics design and rendering. And here we have 4 users collaborating in real time at the same time on the same file. So we've got 3 different scenarios here we're gonna talk about that are also reflected in our design and architecture guides for this solution. This gives you an idea that was a recorded interaction of how vivid and how real-time this actually is. It's rather amazing to me that we can do this not just on dedicated, high-speed connected, co-located workstations, but distributed geographically, and still have the same incredible performance. This example here is very similar to what we actually do in our design paper, where we've done performance analysis of 2 users. This shows 2 users, one using Omniverse Create and the other using Autodesk Revit, but working on the same file, doing different actions in the same file at the same time in real time, each reflecting and seeing what the other is doing. Right? And these can be completely different tasks. Now here is a different example. This shows how Omniverse is very extensible. It has connectors into a wide range of other graphics applications. So this shows a connector from Omniverse into, I think, what's called Grasshopper Rhinoceros. Okay, and this is an example, a little bit different than the other one, that has a more photorealistic image that's being worked on, so that data and physical properties are being specified and manipulated at the same time as the renderings and the colors and the shading are being applied. Looks like that skipped back to the first example. So let me see if I can just go ahead here. The last example I wanted to show in this demo is right here. So this actually, the example happens to be a kitchen design, but this has got 4 different designers all collaborating literally at the same time in real time on the 3D, the graphics files, adding features, plants, cutlery, adding lighting and shading, and adding objects in a way whose physical, they obey the laws of physics. Another example here that's more of an architectural rendering, and then back to the kitchen, right? So these are just quick little snippets, but they're all live recordings of actual sessions that we set up, all being done over VDI. Okay. So what's underneath this? What's under the covers? Well, we've built a reference architecture on Dell VxRail or vSAN Ready nodes with NVIDIA GPUs running VMware Horizon software, together with, of course, the NVIDIA collaboration software. The actual stack that we used for the performance measurements, because we not only design the architecture, we do the performance characterization of this to prove that it's very, very viable. So in our example, we used Autodesk Maya, okay, on NVIDIA, or with NVIDIA Omniverse, and then did the performance characterizations, of which I'll give you a glimpse. And to do the performance analysis, we use the NVector light tool from NVIDIA to measure end-user latency, the frame rate or the smoothness of the image rendering, and the image quality. So there's different metrics that we measure when we set up these cases. And you can't really see this here, but it's all in our design guides, which are located on what we call the info hub here, infohub.delltechnologies.com. You can go there for any of these solution design guides, including for VMware. And this is just an example showing the baseline cases where we characterize a knowledge worker, a typical office worker using Office applications, either in a single thread or in a multi-thread collaboration environment with Omniverse. And then we compare that to the high-performance graphics applications with multiple users running Autodesk Maya. And they're very, very comparable. Of course, the high-performance cases have a little bit worse latency and a little bit less quality, but extremely close, almost on a par with that. And in the short 14 to 15 minutes we have, that's the overview of Omniverse on Dell VDI infrastructure. Okay, thanks.